Welcome. This video, we're going to go over 131 and 132. We kind of went over both of these in class, but if you missed it, here goes. So question 131 says, Lynn's planning to fly from New York to LA. It's going to take the airline when they leave at 8 a.m. The website says she should when she makes her reservation, the probability that the flight will arrive on time is 70%. Or 0.70. Of the following, which is the most reasonable explanation for how the probability could have been estimated? So somebody estimated that, and we're thinking like, how did they calculate that? So this goes to the foundation of everything we've done all year. And what I mean by that is, how does someone calculate the probability of something? Well, we can make an inference about a population from collecting sample data. That is the very essence of what we have done here. And they must have collected lots and lots and lots of information. All that information together would be the population. And picking one or two pieces out of it would be a sample, and we can make an inference about the population from just a sample. So from the question, the probability of the plane being on time would be that, or the probability of it being late would be that. Those are complements. So what am I going to pick apart in here? I read A and it says, by using an extended weather forecast. Well, am I going to use weather to predict chance of landing? That seems low probability. If you fly a lot, most of the time, yes, it's weather, but also there's times where they say, oh, our flight crew isn't here yet. Or they say, oh, we're still getting the engine looked at. Or there's like, oh, we're waiting in line for the runway because there was a backup. So just like you driving in your car to work or to school, a reason why you're late isn't always the weather. B, by making an assumption about how the plane works. Well, we don't calculate probabilities by making some assumptions about things. That sounds a little vague. Now, C, from the fact that all airlines, well, that's not true. Again, thinking about this airline, you probably know if you listen to the news that some airlines are more on time than others, just like some buses. If you've ever taken the bus in St. Petersburg, Florida, some bus lines run on schedule, some don't. I don't know why. Is it the bus driver? Not sure. So we can't make an inference about every plane flying in from California because that's not enough information. From the fact that all airlines, still no good. So E looks like the best information we've collected because we are what we repeatedly do. So in class, I gave the example of a free throw example. So how would we calculate this? It would be the fact that on all previous days of this particular flight, because yes, flights go back and forth all day long. Some flight patterns are multiple times a day. We would collect all that data and then we would just calculate how many times it arrived, and that would help us predict arrival times. Make sense? Next question. Here's a doozy. We're going to review chi-squared. So the question states, here's an experiment, and there's lots of different flower types that have been bred from crossbreeding. So I'm going to oversimplify this and basically just call these M&Ms because this is a chi-squared test, goodness of fit. So when I look at this question, I say to myself, there's a magenta green M&M, a magenta red M&M, a red green M&M, and a red red M&M. And that's all my possibilities of M&M. So I can call up the company of M&M, and this is the ratio I'm supposed to expect, 9:3:1. What that means is that for every 16 M&Ms, 9 are magenta green, 3 are magenta red, 3 should be red green, and 1 should be red red for every 16. So ultimately, as I add up the number in our observation, we observed 217 M&Ms. And so we need to know, well, what would be 9/16 after I added all these up? What would be 9/16 of that? What's 3/16 of that? What's 3/16 of that? What's 1/16 of that? And again, of means multiply. So I go ahead and did that, and I came up with some expected values. So here they are. I expected to get this, but I got that. I expected this, but I got that. I expected this, but got that. I expected this, but I got that. Just by doing the multiplication here. So notice I got 7 less than I expected when I compare these. I got 9 more than I expected. I observed 9 more than I expected. I got 8 less than I expected. I got 7 more than I expected. So these appear to be not totally off, but somewhat off. How does a statistician calculate how far off is far enough off that you do have statistical evidence that is saying that it's inconsistent with what they were supposed to be getting? Well, as we know, it's when we get the probability, is the probability of these observed outcomes, if in fact this isn't true, is the probability less than 0.05. So that's what we're going to do. We're going to use this chi-squared value they calculated for us, and in class we actually calculated this together. We typed this into our table, and we typed the expected values in also to the table, and we calculated an exact same chi-square value, and that same chi-squared value got a number less than 5%. We ended up getting 0.04. Well, let's say you didn't have a calculator handy. You could have Googled a formula sheet. In the formula sheet in table C, notice that we can find this chi-squared critical value. So looking here, we need to look at the degree of freedom of 3 because there were 4 possibilities. So n minus 1 is 3. The degree of freedom is 3. And as we scoot through here, we knew we calculated, the calculator or the problem calculated a chi-square value of 8. So notice that the value 8 is bigger than our critical value. And I'm going to call our critical value 7.81. And the reason why I'm doing that is that anything bigger of a critical value, meaning a number that was too far away from what we expected, anything bigger than that would have reduced the probability of that outcome to something under 0.05. So as we're looking at the table here, we're noticing 8 is less than 0.81. And so now that's where we can zero in. Again, our degree of freedom was 3, which is why we were looking at the table. Where did I jot my table down? I know I jotted it down somewhere. Oh, I made a little notation just like what I zoomed in there. So at the degree of freedom of 3, 7.81. And so notice our critical value is less than that. This is the computed critical value. This is the computed chi-square value. And so that's a match for A. Yes, because the computed value of 8.04 was greater than our critical value. Thanks for joining us for question 31 and 32.